All right. Good morning, everybody. This is the Cluster API Provider Nested office hours that happens at 10 a.m. Pacific Standard Time every Tuesday. Today we don't have a long agenda, but just to let you know up front, this will be recorded and posted to YouTube later today. So don't say anything you wouldn't want to be shared with the whole world. We can get started. I will start off with, I don't have any PSAs. We do have a couple new folks. If you want to introduce yourself, now is your chance. You can just unmute, tell us who you are, and tell us what you're interested in, and yeah.
Hi, everyone. My name is Dan. I'm a member of the multi-tenancy working group, and I've been interested in the virtual cluster project, so I decided to check out this working group as well. I work on operators as part of the operator framework at Red Hat. And yeah, super interested in the project and would like to know more about where you guys are at and what kind of issues you're tackling.
Awesome. Thanks for joining us. Is that cool? I think that would be it. I don't have any PSAs for the whole group. Faye, I don't know if you do or if anybody wants to bring anything up before we jump into the couple agenda items.
Oh, I don't have any.
Cool. All right. Also, because there's only 2 agenda items, if you want to drop something in there to talk about, please do. You should all have access to edit that doc. And then moving on into the actual agenda items. Wei, did you have time to prepare something to talk about syncing CRDs that you wanted to talk about? You're muted if you're trying to talk.
Yes, I can, yeah.
Cool. Should I give you access to, do you need to share screen or you just want to talk about how we're doing it?
Screen. Yeah,
Okay.
share screen. Yeah.
Sounds good. You should be able to share screen now.
Okay. Okay, so yeah. Let me bring this in. Oh, sorry. Okay, so just give a very quick brief discussion about what we did. Can you see my screen?
You can see a Zoom browser window that says launch meeting.
Really? Share screen. Yeah, share this. Oh, okay. Huh? Can you see it now? No.
Still the same thing.
Still the same thing. Okay, sorry, I now use Zoom as much. Sorry. Oh, stuck there. Okay. Can you see my screen now?
Still same Zoom web page.
Okay, let me do again. Okay, let's share screen.
Cool.
Yes.
Now we've got it.
Can you see it? Okay,
Yes.
just do this. So sorry for the small screen. So let me just do this. So basically, I just today I'm going to talk about the CRD syncer we implemented and what we would like to have it more advanced, and what we want to do with the dynamic package. We were looking for to enhance the maintainability of this CRD syncer. So first of all, so this is the CRD syncer we implemented. If you look at this diagram, it's very similar to the standard multi-tenant VC syncer. So we try to reuse as much as possible all the components built by the multi-tenant. And so this is the manager, register, MMC controller, listener, cluster, all this gray colored components, either copy paste the code to the directory or using the standard package from the multi-tenant. So what we really added is the additional CRD downward syncer, upward syncer, CRD controller, and a checker. So all these green components are under the resource directory. And for each CRD, we have one specific, one set of this checker, controller, downward syncer, and upward syncer. So this I will not go to detail because everyone knows very well about this structure. The problem we have to, as I mentioned, is that why we have to copy paste all the code into our directory in order to make this work is because each CRD, if we are not using dynamic package, we have to create another. Let me turn off this one. Okay. We have to use a scheme, the type the client, and we have to build a scheme and let this component use it. So the key things is that this MCC controller, it heavily relied on the pre-built scheme to work. And in this MCC controller as well as cluster.go, this file is all rely on the this scheme, which we modified to add our CRD schemes in it. So this will be importing a special scheme instead of using the standard scheme. And because of this change, we can see that all these other files, cluster.go, listen, patrol, and the manager, all these directory packages has to rely on the MCC controller, need to be modified, just the import part, nothing else. And this is secondary dependency. So and you can see that all this yellow colored is we have to copy paste into our code base, which is very inconvenient and very hard to maintain. So the source directory, we put one CRD and we have two CRDs there. So each CRD has a subdirectory. We put all the checker, syncer necessary into it. This is very clean. And we have to add this scheme.go in order to add in our CRDs on top of existing typed client schemes. So this is the main problem of this CRD syncer is that all depends on the new scheme, and we have to import the special scheme, and as a consequence, a lot of components we cannot directly import to our code base, but have to modify a little bit in the import part to fit the big pictures. So this is of course, a big problem is that we duplicate code and hard to maintain. And the most duplicate code is just because of the imported CRD scheme and nothing else. And I had to commit a PR to use the CA REST config direct import to all the components. This makes another change, which is already in our multi-tenant project, which is don't require any additional, reduce quite much the code that we need to regenerate the REST config for CRDs. And testing also requires some specific fake client instead of using the standard client. So we have to have each CRD have a CRD client implement, not like the standard scheme that one fake client can handle can handle all the standard type clients. So this is the problem we are facing. So now this is why we're thinking of we would like to use the dynamic client and the unstructured structured object to reduce the dependency of the schemes, so that we can leverage the existing multi-tenant component code to use the standard dynamic client and use a generic code instead of we have to modify it, implement each schemes as a hard code one and import by the MCC controller. So this is a very high level view of how this dynamic client works. So basic idea about dynamic client is that they use a GVR, which is a group version and resource, to identify the client and make this searchable and keep the client as simple as possible in this list of the client. And this will be the creation of the dynamic client, and this will be the deployment. And you can see that if we generate this key with a GVR, we are able to find the deploy resource. This is a key, and we can deploy any CRDs, which is a YAML file kind of a format at this example. And we can able to use this one to do a RESTful API call and do this any creation or deletion as we want, because we already have this dynamic client generate based on the GVR. And in order to get this client back, is that we can always use GVR to use that to do all the operation like listing and looking for all information in it. So this is give a standard way on top of the typed client existing in the core V1 to have this implemented, and we can dynamically add in the GVR instead of rely on the scheme. So this is the unstructured object, which is built here, is using this structure to compose a new GVK. In order to get a GVK, we have to use this standard form and the YAML to use this utilities to convert it. And this is why we don't use a hard code Go type. And we can also find resource using the GVRs, which is this format. And the GVR, G is a group version and resource. To compose RESTful API request, which is this RESTful API request, and everything is based on the GVR. So given this new kind of a dimension that we really want to do is this thing. So the object here is not try to dynamically create a client on the fly, but to reduce the dependency and as much as possible, so that all the standard component in the multi-tenant project can be as imported entirely as a package by the CRD syncers if someone wants to implement one. So if you look at this, this is the main purpose, is not is to reduce the dependency. And also, in order to do that, we have to make this dynamic client support in the MCC controller, in the manager, in the cluster.go, in all these files, on top of the existing client operation and the searching mechanism implemented by the multi-tenant project. So there are two things we need to look at. Is that one is the start. The first thing that we have to find a component that's less dependent on all the others, and make this component to read the existing all the controllers, including the standard controllers as well as the CRD controllers. So I think the best place is using the syncer.go files, which is currently exist in the multi-tenant project. We can call this customized syncers. So what this syncer do is that during the build time, and we will compose the entire list of all the controllers in the code base, including the CRD controller as well as the standard controllers. As you know that this is in the register.go files in current multi-tenant project. And we build that one, and when the server starts, and we'll read the config this standard and start this custom syncer. And this custom syncer will get all this mapped list of the controllers, and to start this by the manager one by one. So this is something that we can achieve by using customized syncers. And this custom syncer is only imported by the syncer servers, so that only all the REST package like manager APS MCC controller cluster can be reused by the third-party developer of the CRD controller to import directly. So this is one thing that we can do a slight change and make most of components reusable. And the secondly is that we have to put the dynamic client change in the code of the MCC controller on top of the current client manipulation code. And for example, if we cannot find a type, we probably add in some method to using the GVR to search for the client, and etc. So this is should be the similar to this one, and we can do this client manipulation the same way. And also we can enable the controller to get the access CRD using the unstructured object. So this is also, we can do that to make this available in the MCC controllers. So this is basically the ideas we want to have in this enhancement for supporting the CRD controllers. Yeah, this is all for now. I just have a very brief preparation for this topic.
Cool,
and,
thanks, Wei.
Yeah.
Yeah, thanks for walking us through what's going on there with syncing CRDs down to the supercluster. Cool. Now within this, just to kind of like start the conversation off, I think a lot of this could probably be done with controller runtime and still using typed clients and not actually having to use unstructured, because that's kind of a little bit painful for a lot of people to actually implement. But it seems like if you go back to your last slide, the one before this, we could probably actually use what we're doing with controller runtime. So we're actually using the dynamic clients, but still using typed clients instead. Very similar in structure behind the scenes. Same way that we're going to be building out all the controllers that we want for CAPN in terms of using physical clients, not having to actually go and create the unstructured resources. But I think that makes a lot of sense. So in terms of what we're doing from our CRDs that we're actually syncing, we're currently implementing it the same way. We're basically just forking and then adding in our own resources. And the goal here is really long-term to be able to set up all clients using the actual dynamic client, or do you still think that we should be using the typed client or the full typed clients within the core syncer? Do you have thoughts
my
on
thinking
that?
is we can do a mixed of hybrid mode that in the current multi-tenant component, the standard component, we still supporting the typed client, but on top of that, if we cannot find this, or we can use a GVR, if we user want to use GVR to do the operation, then we switch to this dynamic client. This way, this component will be much flexible and can be support more types. Because most of the code here in the multi-tenant is just start controllers and some of the type kind of operations. There's a field code to do this client. So if we add in this dynamic client, should be about 10% or 50% change on top of existing one. So probably we can make.
Are you able to share the same informers between the two? If we don't switch them, can we still share the same informer between both the dynamic and the type clients? So that we're still using the same cache?
Yeah, cache should be same, because dynamic client is just a way of to searching the RESTful client for a CRD. So you still need to create a CRD at first place. So the CRD still be created in the API server. So once the API server is created, everything informer and all the other things should be the same. Only the client part, which we currently rely on the MCC controller or cluster.go to get this client or get the types, which need to be supporting the dynamic client. But all the informer cache should still keep the same because the CRD itself does not change. Only the way how we look at the client got changed. Now the client was in the list, which is maintained by this libraries, dynamic client libraries. We can get the handle from there. This is my understanding.
Yeah, so currently, yeah, I think currently the way the cache works is every time you add a new resource, you call watchful resource type. There is a method in MC controller which registers the resource to the cache, and we wait for the sync to the object to be synced until everything, before we start the syncing process, right? So
yes.
yeah, as long as you do the same way, I haven't tried, but that's very good to know that we have this unstructured object. If the current informal cache supports unstructured, how does that work? So
no. So I think there is a misleading that the objective here is not to inject the client dynamically while this entire syncer is running. So this is not objective. The objective is to reduce dependency and make the package reusable. So everything is still start from the compile time. So nothing can be injected dynamically, as the name of this dynamic client says. But we just want to add the dynamic client library into the current MCC controller class, so that we have to fix the amount of a controller we want to support before in the build time, in compiling time. Then yeah.
So you still need to have exactly, you need to know the CRD schema, and then you need to register the CRD, otherwise the cache won't work. The whole,
yes, this is the whole purpose. Yeah, the whole purpose is not dynamic, but make sure that since MCC controller support dynamic client, we can still build it, and all the MCC controller can be totally imported directly from the community and reused by our resource CRD syncer. This is the key safe part is that. Sorry. So this is the key benefit of that. It's not too dynamic. So you see, this is the one. Now everything need to be copy paste into our code directory, and very hard to maintain. And if we can all import it directly, all this component is a package, all directly input this one, then user need to maintain this one, should be fine. And this is their user logic anyway, so they can put into their directory. So this make the CRD syncer development much easier.
Sure. Now I understand. So yeah, I think that's a good idea. But let me try to find if we have an alternative way to get the same benefit or same convenience. Is this possible that I know it seems more work, but can we have kind of like cogent tools to generate those files, because they are quite similar for each? So basically, every time you add a new CRD, you use the cogent tools to generate the supported file.
This we did. Yeah, this is everything in the CRD, the cache, the informer, listener, and all generated either using the client gen or using the Kubernetes. And but this part is I'm not including this presentation. Of course, we can generate this code.
Yeah. But another thing is maybe everything that MC controller need to be changed to support a new CRD type. Is it possible to use a cogent for that? This is my question.
Then you have to build it the way in the multi-tenant.
Yeah, but my point is, in most cases, people would need those building types. So I don't see unless you have a case that you only want to sync CRD. But yeah, for that purpose, the import is good. Other than that, if people anyway needs all the building types, so the most convenient way, they will git clone the whole repo and got the default functionality of syncing all the building types. But they want to add more CRDs, then they can use cogent tools to generate the supported code to support those CRD. That it depends which cases has more use cases. I'm guessing the case that people need everything would be more than they only need CRD. So that's my point. So if you have a case that you only need CRD, for example, they don't need anything in the current resource directory. They just want to leverage MC controller, everything that the framework that we have built, a light framework we have built, they can come up with the way that you propose, make the framework even more generic to supporting dynamic types, right? That's one thing. But on the other hand, if people indeed, anyway, they probably don't go with the import path. They will just grab the whole repo and add something like exactly what you do, because I'm guessing you guys need both the regular object syncer and the CRD syncers, right?
Yes.
Yeah.
But we put into a two process. One is called the standard syncer as a process, as a pod. We have two pods. One is the standard syncer pod, another is a CRD syncer pod, because we make it these two entities. It's become two big control plane entities in our code, in our deployment.
Well, why don't you compare? So you don't want to direct fork, or you just want to make the upstream one unchanged? So why not combine them to one? That's my question.
So just sorry.
Yeah, this is we can. Yeah, this is another option. We can do that. Now we unfortunately did this way. We can combine them in the near future, but we just want to make this standard one as close to the community, and we are experienced this CRD syncer as a separate syncer.
Yeah, I didn't get that in the first place. Okay, I thought.
But this is not a big issue. We can combine them together if we want. This is not big issue. Yeah. So the current issue, big issue.
I don't quite understand the intention of you have to import everything, because I thought they are in the same package. Why don't you need to import the entire thing? Now I understand why you want to import the entire thing, because you build it in a separate process. Okay. But
even if we so we prefer that we just use the package directly without any change. So that way, when we do our build system, and it's always can get the latest and try to test it. Unfortunately, because we have to change the code, as you mentioned, probably we can later use a code generator to make the automation to make it working. But still, in overall, still we copy our entire code in and do the modification. Then we import all the package to this CRD syncer. So this is something not very ideal.
So just a few thoughts on like kind of constructing these. Effectively, like it seems like we want to make a library to make it easy to construct
yes.
Controllers that act on arbitrary types. But ultimately, what those controllers do will be reading a resource from one cluster, decoding it into some kind of some kind of structure, applying transformations to that, depending on which direction it's going, and then updating or writing and persisting it into the other side. With the dynamic client, we're moving everything to unstructured, and we're talking about now code generating things to make that easier. I wonder though, like because like you said, Wei, like at compile time, we do have type information available, because the CRD sync, like the separate binary, is importing this library, and it's in some way instantiating it, calling something like a new syncer function. At that point, if we were to pass in a reference to something that implements runtime.object, something that is of the kind that you want to sync, be that CRD or a inbuilt type, whatever, runtime.object, something implementing type meta from Kubernetes, there's enough information there for us to actually not need to use the dynamic client as such, and we could then be using the controller runtime client, which could decode directly into that type, and then actually go and call your like mutation functions and whatever else by passing that along, and having the mutation functions take something like a runtime.object. That's typically the pattern that I've seen with this sort of a thing. And there's actually a couple of cases in the core code base which are a little bit different because they don't use obviously controller runtime. But there are a few cases of constructing controllers dynamically like this, and I wonder if that would simplify things, because that same package could then be used by the main KCS, the main, what do we call it? Cluster API nested or virtual cluster project in order to construct all of those core inbuilt things too. So that way we only end out with one underlying thing. And if you were to compile these all together, they'd all share a controller runtime client too. So I think the informer stuff there and like sharing informers and indexes should be more easily resolved without having to manually work with the underlying layers.
So I think this is one other direction that we still need to change a little bit the current MCC controller code, because this one is already hard code. When we get something, they go scheme. So if scheme does not exist, they will fail. So if you want to use a full reference kind of approach, I haven't looked at this direction much. Thanks for bringing it up. But still, we need to make the MCC controller and the cluster.go or this existing component to handle this reference. We still need to do some modification on some of these files and let them to able to support reference. And this is another approach. I think this is maybe achievable. I haven't looked at this one. This is a good point. So why not just impose unstructured in order to, what difference between the two, the benefit, or is this reference much easier, or it's because the unstructured is kind of a official supported structure, correct? It should be, in the long run, there will be more benefit.
So I wouldn't recommend, so the unstructured approach, it does work, but you are basically disregarding all the type information that you have about that object. It is officially supported in that it's in the core code base, but it's typically being used for things where you are dynamically, like when you don't have any type information, even at compile time, dynamically establishing watches. So if you were building something where you wanted to say at runtime, configure to sync from like some new API type, the unstructured client could be used there because, like you noted, you only need the API version and the kind, and you can start watching and establishing informer cache and everything, and it will decode into unstructured because that's dynamically registered at runtime, so you don't have any of that type information. But because what we're basically making here is making it easy to create new syncer components for different kind of API groups or whatever else. You know, we've got our core ones here and then whatever CRD types. We do have that type information, so we can decode straight into there. And I think you're right in saying it's not absolutely essential, but it does make working with all of these things a lot clearer. And I think as soon as it comes to actually writing any of these syncers, you're suddenly having to work with kind of JSON style things. Like the unstructured is a map string interface, so you're having to cast your structs all the time. You're having to do quite a lot of things there in order to kind of modify or mutate any data, as opposed to just working with those standard like core v1.pod types that we could be using.
Okay. Yeah, I think good point. Yeah. But I should ask for the Chris and Faye or other folks. Even though in this talk, I'm not thinking about dynamically inject this new types in, but is it long run? We do hope that while we're running the syncers, if user have somehow get the CRD want to sync. For now, we have to stop the syncer and rebuild it. But in the long run, is it another possibility to inject it while this VC syncer or whatever the future syncer names, we can try to do the CRD syncers? Is this something we are looking at? If we're looking at it, I think the unstructured can help on this front, really do the dynamic kind of injecting.
I think that will, you know, when that is a requirement, I think it does make sense, but I also don't think, like, that's quite a complex problem domain, because as soon as you need to apply mutations to those objects too, it becomes very complicated. And from a like isolation perspective, allowing dynamic configuration of bubbling up those resources is potentially quite problematic. And I wonder if maybe, bear in mind, we already have an approach now where we can have different syncers. You can have multiple different syncer binaries and components running. That could actually be like almost a separate implementation that we look at further down the line, I wonder, instead of hindering and making it harder to work with the existing package today for what we're targeting?
Yeah, because the problem is our Sinker is not directly, unmodified object copy. No, we have so many mutations because for I would expect even for CRDs, you probably have some mutation take some places. If you do that way, I really don't think dynamic inject code we are making simpler. So to me there are a few things. So I think we definitely should support CRDs, and my currently thinking is a better way is we can have some codegen to help people to generate all the required files as a scaffolding code. Then they can add their logic to mutate all the objects they think. And I wish they can share the one binary. The reason is that based on my experience, so even depends the CRD type, but since the CRD is so flexible, it's highly possible when you do the mutation, you need to reference other objects like parts. So for example, if you are syncing a controller CR, if you probably need some part information. So if you do that, you have to populate all the cache with all the parts. That's probably a big waste because you cannot share the same informal cache with a default upstream syncer. So for that purpose, maybe combine them in one binary can save some more resources. That is my thinking. Definitely decouple has its own benefit, like easy maintain. There's separate, clear separations, easy code maintenance, something like that. But for me, I think for the long run, if I want to enhance Syncer, I would like to enhance it this way. So let people easy to add CRDs. But at least for now, don't dynamic inject things.
Okay, yeah. So now we have three approach. One is the instructor, another is James you mentioned using the reference. I will take a look, and the third one is Faith mentioned that to try to use some code gen to make this work, correct? So we have three possible approach, which is I haven't looked at the third one and the second one. So I will take a look at the one at a time and the third one, the second one, see which is which much easier. If you have any ideas which tool you want to use, just share with me so I can take a look.
Let's open an issue on either the multi-tenancy repo or CapN as well on this way. And then what we can do is we can actually start working on a design doc that we can talk about a little bit more in depth as we go forward with it. Because yeah, it seems like the most flexible and supportable way of moving forward would probably be just to get to swap out the actual client within the syncer, the actual syncer, so that it can support multiple schemes, so that we could do things like having what we talked about last week on the call, where you could set the tenancy.transfer, forget what the actual label is, but the annotation that allows syncing back and forth that we use for storage classes, for example, and priority classes. Being able to use that directly from the syncer would at least sync the CRDs. And then I think we can continue to build out, like everybody else is talking about, libraries to support syncing other resources, so that you could build your own syncer if you needed to, or if somebody wanted to, they could fork this and add their own into it, but they wouldn't have to go and change everything in MC controller. But not to over rotate on this, because we did spend like 40 minutes. Can we open an issue on one of those two repos, and then we can start a design doc that we talk about this a little bit deeper?
Okay,
does that make sense,
sure.
Sense everybody?
Yeah.
Cool. All right. Moving on a little bit. So I wanted to bring up real quick, that'll be a 2-minute conversation. I brought up the idea about using the cluster add-ons declarative patterns project to the cluster add-ons group right before this meeting. They didn't have any major feedback in terms of concerns about doing it. There was some feedback about whether supporting the entire control plane in one operator versus doing individual components could work. Whether we were to have, say, for instance, a single controller for the API server and controller manager together instead of having those separate. I think it's an idea. There's concerns that we wouldn't be able to orchestrate both sets of those add-ons based on the way that the libraries are set up in a single controller, which might mean that out of the box we do want to continue to keep them separated. I think from specifically around upgrades, being able to say only deploy the new API server binaries, but don't add the new controller manager binaries, for example, or pods, for example, and keeping those separated. The biggest issues between that is making sure that when one is updated, we're making sure to either wait or what the orchestration layer is for that state machine between the two, which is going to be the biggest thing. And I think that can all end up at the NCP controller for orchestrating all the resources. So I don't think it's going to be a huge issue for us. But they're all supportive, and if we need any changes, we can go work with anybody in that group as we start to build out those controllers. And then in the last 15 minutes, I want to talk about two other things. James, you have an item on the agenda. Do you want to talk about that real quick?
Yeah, if you want to go in first, and then we can just use the time at the end if you've got two items.
Cool. I wanted to not end this meeting without talking about next steps. So that's the main thing. So Chao, thanks for putting in that first scaffolding PR and getting that all set up. I assume you're picking up the nested etcd because you're still assigned to that?
Yeah, right, correct.
Okay. Mm-hmm. Cool. All right. And then once that comes through, I'm still working on trying to get time set off to actually work on the NCP controller doc. Apologize for not getting to that. What is next? We still need to do the nested API server and nested controller manager. Since we have everybody here and we do have base scaffolding set up for some of these things, is anybody interested in going and assigning themselves to one of those controllers? If anybody has time this week. Those issues are open on the CapN project. You're more than welcome to just go assign that to yourself. If not, we'll try and figure out who from our side of things can pick things up.
Yeah, I think probably not this week, but we can definitely pick one. Maybe API server.
Okay.
Yeah, but we will, yeah, at least we will pick up one. No problem.
Sounds good. Cool. And yeah, we should definitely pick up something from the Apple side of things as well. I don't know if anybody on the call wants to call that out now, or we can self-organize internally outside of this. And then James, I can now give you 15 minutes to talk about what you brought up.
Cool. Do you want to provide any background on the cluster, like what brought this up?
Yeah. So a little bit of background. So we have internally been trying to work through how we're going to do admission control, basically, admission webhooks. And so we've all been having a bunch of conversations about how to navigate from a control plane API to the webhook, to the actual webhook endpoints, in essence. And so this sparked a conversation of, okay, the network stack that is deployed as a tenant control plane is actually pseudo different from the actual network stack that it's truly exposed at. And you all, Faye, what we're talking about here is basically the cluster IPs being different between tenant and supercluster, and how that breaks the way that you would actually navigate from, say, for instance, the API server, because the admission webhook could be registered at some service name, but when it actually routes to that, the DNS isn't set up properly in the Kube API server because it's using cluster DNS, so it has the wrong prefixes, so on and so forth. I brought this up a long time ago, and we're finally trying to look through different ways of looking at this. And so James brought up an idea around doing some syncing instead of proxying instead of syncing. So that's the background.
Okay.
Yeah, so it was kind of off the back of the fact that we're kind of dealing with situations where we're either having data defaulted by the tenant API server, which then gets persisted to the tenant etcd and then needs syncing over to the control plane one. And now, because that field's either immutable or can't be set by the client, or it's allocated, we end up with issues there. I guess it just kind of prompted me to think a little bit about the differences between syncing and proxying with this sort of a model. So right now we are effectively using the tenant API server as like an intermediate data store between the supercluster and the client. So client data goes, to the tenant one, gets persisted. The standard defaulting, any other kind of options that we're used to in Kube API server happens. and then it goes to get moved on. And it then occurred to me as well, things like resource version collisions and stuff like that aren't going to be honored as a result, because we are buffering it elsewhere. They are technically different objects, which we're then mutating just enough to be able to submit them and apply a patch to the supercluster. So it started to make me think as well, when you said the IPs are, you know, they're different, they're allocated by two different things, and the network stacks are sort of different. That in a way, what we're trying to do for users is present a different view of the supercluster to those users. So the definition of list all namespaces is kind of different. It's like the data is ultimately the same, but when you say all namespaces, you actually mean all namespaces with this particular prefix or something along those lines. So in a way, it's almost like a data transformation thing. You're presenting a different view of that data to the client. And if you take that to and continue with it, the differences are quite stark in terms of like the model and the problems that clients will face. So if we dynamically, like when a user, if we change the model to, instead of persisting to an etcd in the middle, if instead a client goes, submits a resource into namespace, say named default, the API server that they're talking to, instead of persisting that itself and then having a syncer move it across, that API server could actually apply those same transformations that we run today, those mutations, before responding to the request, and then submit that and forward that request on to the upstream supercluster. That way, you basically block those, like a create operation on the tenant API server will block until that has actually been submitted in the supercluster. And then the resource there that's returned from the create operation from the supercluster can be mutated back into a representation suitable for the tenant clients. So basically removing those prefixes from the namespace name, or resetting or setting the correct, there's actually not any resetting or overwriting to do, but basically responding that and passing it back on. So the idea was basically, instead of having syncing, you would have a custom API server that for the resources that we sync today, instead of persisting those into etcd, would proxy, like transform them and proxy them through. And then for all the resources that today we don't sync, because we don't need to sync them, you know, the custom resource definitions, the cluster scoped things, they would still be persisted into it like a tenant etcd. They still get their scoped view, but the API server is effectively brokering this communication. And it reminds me in a way of kind of conversions between API versions. It's not the same thing, but it's kind of manipulating it to present a different view so that the clients can all interoperate. And yeah, it would mean that we don't need to do things like handling spec.cluster IP on services being allocated in two different things, because the API server would basically be deferring all of that. And it's a similar thing with node port. It's basically the same with everything, even defaulting functions. Right now, we actually effectively run defaulting twice, once in the tenant API server at whatever Kubernetes version that's using, and then that goes and gets submitted on. And in fact, it kind of gets even more muddied because it gets defaulted on the tenant one, and then it gets submitted with those default values set explicitly. So the supercluster isn't actually getting a view of the user request. It's getting a view of the user request right now after defaulting has run at a particular Kubernetes version. And I worry that as the project matures and we see more deployments of this, and actually you get drift between the supercluster version and the tenant cluster version, that could become more and more problematic. And you might get into situations, well, more and more situations where you're having to have explicit handling for certain types of fields being set or not set, or certain fields not existing in one version and only existing in the other. So it's definitely quite a large topic. And I'm obviously aware that it's quite a fundamental shift in like that architecture, but I thought it'd be worth bringing up to kind of bounce some ideas around as to other ways that this could be done. And yeah, sort of start thinking about pros and cons. Is there any thoughts or questions?
Yeah, I can tell you my immediate thought about this. So, so intentionally, you want to make the source of truth to the super instead of tenant for certain objects, because.
Sorry, say that again?
Yeah. So essentially, you want to make the source of truth change from the tenant to the super for certain types of objects, such as pods, namespace, service. My biggest worry is that because tenant can install any type of controller. So if any of the controller mutate objects, that would be a trouble, because you need to think about how to, so then you need to answer the question, who maintains the source of truth? If you have a tenant operator change any, because tenant thought I'm the source of truth because I own this, then, but in the end, if any of his change are overwritten by the supercluster because super think I'm the source of truth, that is my biggest concern, because this problem is hard to resolve architecture-wise if you change the source of truth. Other than that, you architecture-wise just make as a write through cache kind of thing, which seems okay and indeed solve some problem like the class IP problem. So my biggest worry is conflict with the user, because how do you tell user that, oh, this part of the resource are not owned by you, are owned by the supercluster, but that type of resource are owned by you. So how can?
So I don't see it as a change in ownership personally. It's kind of, this is true as it is today, right now, with the way we're syncing things. You're updating objects and then they're getting synced. You could write a controller in your tenant that manipulates service objects, for example. Now that problem still exists, that tenant controllers as well as supercluster controllers could be manipulating those same service objects. In fact, the situation today is kind of worse because the optimistic concurrency guarantees that Kubernetes and its API server provides are lost. We can't now rely on resource version to prevent us stomping on each other. So by switching to something like this, I actually think it aligns it closer to, I think it makes it basically the same as how Kubernetes operates today, like when you're talking to a regular API server, because all of that sort of conflict over who's manipulating what field or whatever else is handled by the regular optimistic concurrency bits. The ownership thing, I don't quite see what the difference is. Basically, there is no concept of ownership in this, really. We've just got clients interoperating and working together on different types. So, yeah, I wouldn't say like the ownership has shifted at all. We're no longer having an intermediate store and then syncing that representation in that store and like resolving these conflicts, if you know what I mean.
Yeah, so what I mean ownership is because the current logic is we have a clear, kind of definition. We're trying to maintain is, okay, the spec, the source of truth is the tenant. So everything that the tenant change on the spec, you will be populated to the super, right? So if you change the way, like if super is the, if we change the design, like, everything, the client is just copy everything from the super because things created in the super, which means everything changed in the super, for example, the spec, we will copy back to the client.
So it wouldn't be copied back to the client, though. That is just the view of the object is just in that state. So when the client then goes and gets that object, it will see that current state of the object.
Oh, yeah, it's not a copy. So, but how about, so you are saying that if tenants change those things, it will be directly, I see. So you are saying that change will directly persist to the supercluster.
It's not even replicated. That's the only place it would be persisted. Basically, right now, I'm saying instead of having two sources of truth, which is kind of what we have two sources of truth for every pod, for every service, because we persist it into the tenant's etcd, tenant clients apply changes to that version of the resource, and then the syncer is having to resolve conflicts and merge these back and forth. Instead of that pattern, I'm basically saying that the clients basically get to interact with the supercluster's copy or version of the resource, but because we obviously want to present it as a scoped thing, the API server has to do things like rewriting namespace names to remove prefixes or add prefixes, depending on which direction it's going. So that tenant API server basically becomes a lot more the conversion logic that currently exists in this syncer basically shifts into the tenant API server, and then the tenant API server is acting as a proxy through to the supercluster whilst applying that conversion or mutation logic. So they end up all working on a single copy of that data, and instead of having multiple sources of truth for those, we only have the one. It might help if I write something down instead of talking about it.
We can continue to have this conversation since we're at 2 minutes until the end of this, but we can continue this async over Slack and meet together next week as well and see if we can talk more a little bit about it as we continue to kind of think deeper into this. But I'm glad that we got this at least out in the open to talk about, to start thinking about, because it is gonna make it difficult for a tenant control plane to operate, to use the standard functions, to do things like deploying, say, for instance, cert manager, and even getting the right cluster IPs to associate with the workload or the search certificate that it's generating. All those kinds of things we need to kind of work through in the long run.
Just one quick question is that are everyone ready to have this kind of big shift?
It doesn't have to be a big shift if it doesn't. Like, there's probably an elegant solution if we can keep working through and talking about it.
So this is all the difficulties or complexity is hidden by the syncer or whatever mechanism we use. Everything provided to the user doesn't change. So it's everything. So yeah, I need to think about it more. It's we are all the controller work, informal cache things kind of work. If you're missing that part of thing in the etcd, that's my concern.
Sorry, I missed that bit with it, but yeah.
So you say so there's something that so basically for the cluster state they are split into two etcds, right? There are one etcd in the super provided the parts. There are one etcd in the tenant provided the rest of things, right? Yeah. That's your model.
That's effectively what we are. If you look at virtual cluster, that is ultimately what we're trying to achieve, right? Deferring the scheduling domain, the actual running of workloads to one centralized supercluster, but allowing the user to interact with that as if it looks like.
I understand, but I want the duplication indeed has that benefit. For example, for whatever reason, if the supermaster is down, but tenant master still work.
So if the supercluster goes down, then you wouldn't be able to, do a pod create operation. No, you would get an error with that. But right now, I think that's a truer representation. Right now, that resource would be persisted into the tenant etcd, and then it would sit around and wait. Whereas here, we should really, in like true Kubernetes fashion, if the API server's down, they should get a 503 error or something, right? We kind of lie because we've got a write back cache. Sorry, I know we're over now. Charles was about to say something.
Yeah,
I'm just gonna
I just have a quick question. Do you have anything like a description of the idea, like draft or docs?
No,
I wanted to go through the details.
I haven't.
Okay.
Really helpful for me to have. Yeah, and I'm very aware of that. Let me write.
This is Nick. As I understand it, all you're talking about is proxying directly to the master API server instead of caching into a different etcd in the interim, right?
Yeah, for the types that we currently today sync, yes. So like workload.
Which are pods and scheduler related things. Yeah. I was trying to think about this from another perspective. Like, what if we could, have, let's just say, the cry layer could actually plug into Kubernetes and create pods in place of containers. So like you'd have a plugin and then you could run like something like kind with a different cry that spins up pods instead of other things. But sorry, I digress. This is more of a multi-tenancy thing than a CAPN.
Yeah, for fear of dragging it out too long, I might message you about that instead, because I can see Chris sitting there like wanting to call it. It's 2 minutes past.
No, I just want to make sure that that folks are able to stay on. If we can continue the conversation, we don't have to end. If everybody's still available and wants to continue.
I'm
Cool.
free for a few more minutes?
All right.
I'm okay. But from my side, I have totally reversed the thinking from James' proposal that James' proposal is put everything into a supercluster and put the tenant API server as a proxy. But my thinking is really to make really truth of everything into tenant clusters and make even a scheduler in a tenant API server so that the tenant can really access the pod, the created pod, and put everything in tenant cluster and make the supercluster a kind of supporting role. So this reverse directions, I think, really distributed the load relatively nicely, because now we have the problem bottleneck that the etcd API server on the supercluster. So if we can move more rows to the tenant cluster, this will be a better distributed way. So I'm looking at this direction, and probably we can talk more. But I think if we can put the scheduler really into the tenant cluster, make it really tenant API server a real one, probably can be a lot of we can see even more things happening.
The biggest problem with that is the network domain, because that's really what we're talking about here. Because the
we
scheduling domain is what runs the CNI.
Exactly.
Yeah.
And I can look at this one. There is some examples in the source code in examples, which is I'm interested to look at this network part. That's how we can make it work. Still, I think it's still achievable, giving different project around. So if we can make this direction move, probably can even save some of the work.
I think it would be, like, from my understanding of some of the goals of virtual cluster was to do exactly the opposite of that for workloads, at least, which was deferring the scheduling, like utilizing the supercluster as the scheduling domain. So not exposing things like node objects to that supercluster, or even like cluster topology, really.
They still do, though, because nodes do end up associated with your cluster. They're just shared nodes. They're just it's a weird little wavy line there.
I think if we run a scheduler on the tenant side, we end up in, like, you end up having to expose, potentially thousands of nodes to the tenant cluster, and then start doing.
No, we only expose some of the nodes to the tenant cluster. So this is why the supercluster have a supporting role here to manage how much node can be exposed to the tenant cluster and how much is to another tenant cluster. So this is a supporting role played by the supercluster that decide how much you can do. So once the tenant have this amount of a cluster node available, he can play whatever he wants. And if he wants, he can dynamic adding more node.
So, but to me, the model, the number one, as James said, the number one reason I want to come up with things is share the resource and use a single super scheduler to increase the node utilization. So in your approach, to me, it is as simple, and it only work, you have a dedicated nodes assigned to the tenants. And you expose those dedicated nodes to a tenant API server. That I think it should work.
Not needed necessarily node. The node can be virtualized as well. So there's nothing to be,
But if you have a tenant scheduler, the biggest problem is if you have two tenants, they run their own scheduler, but they share the same node, you will have a conflict. And those conflict is hard to be resolved.
No. This is why we need a supporting role played by the supercluster to make sure this conflict never happens. So there is a precondition. We can, there's nothing you can do to really have a multiple tenants play widely. Compete with each other. We have to have a really controller on the bottom.
The problem is if you want to have an arbitrator to do the justify to see which one is valid, because you have concurrent placement, right? You need to justify which one is valid. Then that role, if you think supermaster need to play that role, they need to know all the scheduler current distribution. They need to have plugs to see two schedulers, the whole cache of the two scheduler and their own caches. They need to have a global view, all the object resource allocation. You know what I'm saying? Otherwise, how can they justify the node is full?
Yeah. So this is why the job is distributed by the two levels. One level on the tenant cluster is just locally optimize whatever they want, given the resources. But on the supercluster level, his job is just make sure you divided it nicely, so that's the tenant cluster not conflict with each other.
No, the divided things is as far as I see. Otherwise, you have to either change the tenant scheduler. Every time they make a scheduling decision, they need to call another global arbitrator to see if my scheduler is conflicting with others. So you need to have a locking kind of thing, update the global cache. This is one way. Otherwise, if you share the same node, you will have scheduling conflict. The simplest thing is if if they don't share node, these things should work. But as long as they just start sharing node, the two levels.
The simplest answer is that we don't share nodes. We don't share nodes. If for example, if the tenant wants this kind of resource, he will ask for it from the supercluster, and the super gives them, and he can freely play in this scoped domain. There's nothing to share with others.
Yeah, if you don't share,
tenant,
that's kind of counterintuitive to my my intention, because I want node to be shared. I want to entail the node resource utilization is getting higher and higher. Otherwise, our approach has no difference compared with multi-cluster approach.
Right.
Each tenant have dedicated cluster. So
you might as well just reconfigure the kubelets to point at the tenant API server and make our lives a lot simpler.
Yeah, definitely. Cool. All right, I'm gonna call this right now, and we can continue this async on the CapN channel on Slack, and then and let's get a doc written as well that we can continue to move this forward separately. Sound good, everybody?
Yeah, James, that's a good idea. I think about it.
Cool.
Anyway.
Thank you, everybody, for. Go ahead, James. Sorry. All right, cool. All right, thanks everybody for joining. This will be posted to YouTube a little bit later, and then we'll resync next week on Tuesday.
Sounds good. Bye.
See y'all.